Let's talk about the terms associated with a polygon. In this given practice exercise, we are given with a polygon here, and we are tasked to determine or name the sides, vertices, interior angles, the given exterior angle, the possible diagonals, and the name of the polygon itself. Take note that we do have hints here that when we talk about sides and diagonals, they are actually line segments. The vertices are points, and the interior and exterior angles are, from the name itself, angles. So let's try to answer number one. When we talk about the polygon here, the polygon is just the figure composed of this area here. The extension for this side here is not part of the polygon because as we define polygon as a closed plane figure composed of interconnected straight line segments, this line segment here is just an extension of line segment AB coming up with an exterior angle to which we are going to name in number 4 later. So our concern for the sides of the polygon is only are the sides that are only possible for this given figure here. When we talk about side, the first possible answer here is the side AB. But when we write side AB properly, let's remember that this side here, are also line segments. So if you're going to say AB, we need to use the proper notation for line segments with this bar at the top. So this is the first side of the polygon here. That will actually be continued to this area here, which is the side BD. And then just continuing the counterclockwise motion, you also have side DE. Before I complete or end the item number one, let me just remind you that sides here are actually line segments. That would mean if your answer for the first line segment or first side is a line segment BA, it is actually the same as line segment AB. And it would be incorrect if you're going to use here the same notation. The point here is that again, you may interchange the endpoints of line segments and they will mean the same thing. And writing them together as part of the task will actually invalidate that item because it's just a repetition or a duplication of one side. So let me erase this. And with that reminder, let me just add here the last line segment or last side, which is the line segment composed of line segment AE, or you could also say EA, as long as only one of those two possible notations will be written here. So we are given here with 4 sides of this polygon here. So if this is to be defined later as what type of polygon, simply look at the possible, the number of sides presented here as 4, and we could actually determine it as, or this polygon as a quadrilateral. But that is not the concern for this practice exercise. Let's proceed to item number 2. Aside from determining the sides, we could also determine the vertices of this polygon here. As mentioned, the vertices of the polygon are the common endpoints of each of the sides or each pair of sides. Okay, so if we're going to look at this polygon here, the first vertex is the point A. Let me change the color. Point A, as it is the common endpoint for side AB and side EA. That's our first vertex. And since vertex is a point, we just simply need to use here a capital letter corresponding to the proper naming of point. Other references we'll use here, the notation at the top, but for us not to be confused anymore with other possible notations later on, let us just use capital letter. The next vertices are B, D, and E. If you're going to interchange all of this, it's okay because we are just determining the number or the name of the vertices. So whichever comes first, it will not affect the fact that all of these 4 points are considered to be the vertices of the given polygon. As for number 3, we are to determine the interior angles. If you can still remember, the interior angles are the angles formed and are found in the interior of the polygon. So the first angle is for the angle wherein it's the vertex is A. So we could use here angle A. Let me use other color just to differentiate them. So you have angle A. The second angle is angle B. However, take note that the vertex B is shared by two different angles, one of which is this angle here, which is considered to be the interior angle or one of the interior angles, and the other angle, which could be found on the other side, which is actually our exterior angle in this given figure. So how could we differentiate or state that if we say angle B, we do mean the angle or the interior angle here? For us to do that, we let us go back to the proper naming of angles. Take note that in the previous lessons, if we if of the vertex of an angle is also the vertex of the other adjacent angles, we cannot use the naming of using one point only. So instead of saying angle B, we could just simply say or use the three vertices, not necessarily vertices, but 3 points. Yes. So you have angle. We will start with A. We will place B, the vertex for that angle in the middle, and we will have here angle D. So we mean by this angle is it means this figure here, so that it could be differentiated with the angle later, the exterior angle, which also uses the vertex B. So if we are going to do that, for the first item that we have given here as angle A, we could also accept the naming of this angle using 3 points. You could also use here E, A, B. And also, we could also accept BAE as long as A, the vertex that we are talking about, is located in the middle. So if for the second, that's ABD or also B or D rather, BA. You could also do that. Or let's just simply write it here, BAE. As for this, you could actually accept angle D, BA. If you're going to name angles with three different points, the middlemost point is the vertex of that angle. So the remaining angles here, interior angles specifically, are this angle here and this angle here. So for this angle, you could have angle BDE or the other way around, counterclockwise motion of points. You have angle, rather clockwise, EDB. And finally, for this angle here, we have counterclockwise angle DEA, or the counterclockwise motion, you have angle AED. So as you have noticed, we also have four different interior angles here. Okay, as it was also the connection of for number one and number two, that we have four sides, we have four vertices, and we do have here four interior angles. And again, as I mentioned earlier, this polygon is a quadrilateral, and the most complete definition of a quadrilateral is a polygon with four sides, four vertices, and four interior angles. Let's proceed to number 4. In number 4, we are going to name one exterior angle. In our given figure, we have the exterior angle here, The exterior angle, as a reminder, is an angle formed when one side of the polygon is extended. So we have extended here side AB, and we pick a point C on that extension, and the angle formed of this extended side and the other side is now called to be our exterior angle. And since we have used 3 points earlier to determine this interior angle here to differentiate the exterior angle for number 4, we are also going to use 3 different points, and that would be the angle, this one, so DBC, or angle CBD, this here. Okay. Another thing to consider when we talk about exterior angles is this. Make sure that that exterior angle is forming a linear pair with one of the interior angles. So this is really an exterior angle, as this angle is with this interior angle rather are forming a linear pair. Now, let's proceed to number 5. For number 5, we are tasked to determine the diagonals that could be present in this polygon. But we cannot actually determine the diagonals immediately just by looking at the figure, because diagonals, as defined, is a line segment drawn by connecting two non-consecutive vertices. In this case, we are still going to draw them to determine what are those diagonals. So when we try to draw the diagonal for this given figure here, we are going to connect two non-consecutive vertices. So if we are going to choose vertex A, one of its consecutive vertices is B and the other is also E. My point of emphasizing that is, since points B or vertices B and E are consecutive to A, we cannot connect them and come up with a diagonal. Because if we are going to connect them, we are just going to make the side. So the only non-consecutive vertex for vertex A is vertex D. And if we're going to draw a line, that would be our diagonal. And the name for that diagonal is diagonal AD. And per definition, it's a line segment. So we use this notation to, to label it properly. The second lines, the second possible diagonal that we could draw here is by connecting the non-consecutive vertices B and E. And the name for that diagonal is diagonal BE or EB. It's okay to interchange them. Just make sure that it is actually with this notation to denote line segment. How about if we are going to connect C and E? Since C and E are non-consecutive, what do you think? Is it acceptable? The answer is no. Why? Because if we talk about diagonals, we are connecting non-consecutive vertices of the polygon. Point C is not a vertex of a polygon, because again, point C is just an extended portion of this one here. And with point C, it does not, or it did not close the figure. You might argue, sir, I could close it here. I could close it here, and then I could draw the diagonal CE. Yes, that's correct if you could close this one, but we are just referring to what is given. So since C is not a vertex of a polygon here, of the polygon here, we cannot draw that. That would mean we only have two diagonals here. And then finally, for number 6, we are now going to name this polygon. As I have mentioned earlier, this polygon has 4 sides, 4 vertices, and 4 interior angles. So we could actually use the name of a polygon having 4 sides. And we can call this as quadrilateral. lateral and use the vertices in either clockwise or counterclockwise pattern. So if you use counterclockwise, you have A, B, D, and E. This is the first name of this polygon. For clockwise motion, you could also name this as quadrilateral. We still start with A. So A, E, D, and B. These are just two of the possible names for this quadrilateral because we have started with vertex A. If we are going to start with vertex E and do the counterclockwise and clockwise patterns of the vertices, we could come up with more possible names. The other way of naming this is by also using a figure. So instead of saying quadrilateral, you could also use here the symbol for quadrilateral, and then you could use here again the vertices A, B, D, and E. So for the second name, possible name, you have the arrangement of the vertices A, E, D, and B, and you could again use the same notation for quadrilateral, and that is its other name. So these are just the variations of the names. Okay. So for this practice exercise, we were able to determine and name the parts and important um, terms associated with a polygon. Right? And are actually very important as we dig deeper on the relationships of measurements, probably of angles and sides of the polygon. Measurements of angles and sides of the polygon. So please stay tuned for the other videos and please review this as you prepare for our assessment soon. Goodbye, everyone.